And yes, it's Tuesday afternoon. It's time for Creation Ministries International. And today we have a very special guest, again from Creation Ministries, Dr. Tas Walker. Good afternoon, Dr. Tas.
Oh, good afternoon, Mick. It's good to catch up with you again. It's been a little while, so it's great to be here.
Oh, it's awesome having you back on again. And of course, Dr. Tas has a Bachelor of Science, Earth Science with first class honours, Bachelor of Engineering with honours, and a doctorate in Mechanical Engineering, all from the University of Queensland. And we're being told by Dr. John last week that you are the man to ask when it comes to dating. Things like, we have talked about how scientists and geologists are always sort of throwing these huge numbers around. You know, the world is millions and billions of years old, and we've talked about carbon dating before. Dr. John sort of gave us a bit of a rundown on carbon dating and how it only works for tens of thousands of years, and even then it's got issues. But there's other forms of dating because, of course, to come up with millions of years, you can't use carbon dating. And we're told, Dr. Tas, that you're the man to ask. What other methods of dating are there?
Well, there are lots of different methods that people use for dating. And in a nutshell, if we just cut to the chase, there actually is no scientific instrument that can measure the age of anything in the past, not by making measurements in the present. That's the key thing to understand. But scientists, they use lots and lots of different methods, like, for example, potassium argon. Potassium, that's something used in matches, and argon's a gas. So they do. That's a very, very popular one. Lots and lots of rocks are measured using that method. There's other ones. There's samarium neodymium. There's that one, and then there's a huge number. I guess you could say dozens and dozens and dozens of methods. That's all to do with radioactive isotopes or radioactive elements which decay. And so
is that the same as radiometric dating?
Well, that is. They call it radiometric because it's radioactive elements, and they use radioactive isotopes. So that's why they call it radiometric. Although, one textbook that I was reading and I've used by a guy, he doesn't like the word radiometric because you're not actually measuring a date. He'd prefer to call it radioactive dating because you're measuring what you're actually measuring are the various elements or isotopes that are in a sample. It might be in a crystal or it might be in a whole rock or something like that, and they put it in a machine which measures these things, and they're very accurate, incredibly accurate, to something like 8 decimal places, one in 10,000 or one in 100,000. That's how accurate they are. Mm-hmm. And so, but you're not measuring an age. You're measuring these elements. So how do you get an age? So basically, it all depends on assumptions. You have to make an assumption for how you think those isotopes got into the rock and what happened to them after they were in the rock until the time that the sample was collected in the field. So that's the thing is, I always say, the key take-home message is that there is no scientific instrument that can measure the age in the past. All ages are based on assumptions. And the third thing is you can get any age you like depending on the assumption you make. So in a nutshell, that's it. And so basically, and the other thing is, this is really interesting, is that no scientist or no geologist believes the numbers that come back from the laboratory unless they are about what he expected them to be, and so he doesn't believe them either. And it's interesting to see some of the discussions that go on in the literature about people disagreeing about the ages of things. And it's sort of, it's easy to appreciate, really. For example, I was talking to a person just recently, and we were talking about this, believe it or not, and they were saying about how accurate they are, or they thought they were. And I said, I looked at my watch and I said, I got a really accurate watch here. This is, it's it's got a great quartz crystal in it, highly precise. I said, I can read it now. How long have we been talking? I'll read my watch.
Mm-hmm.
And they said, well, you can't tell because you didn't read it when we started. And that's the whole point. You can't read it. You can't know until you actually read the watch when we started. And it's a bit like that when you're cooking something, you think, oh man, how long's it been cooking? I forgot to start the timer,
Yep.
So that's the basic issue with all dating methods. And the thing is, people think that they are so precise, so accurate, so reliable. But really, the whole thing is driven by a belief system which requires millions of years in order for evolution to happen. So that's basically it.
So with this radiometric dating, tell me if I'm right here. If I wanted to figure out how old a concrete slab is, like let's go, 1,000 years into the future, and I go, okay, now I'm going to tell you how old this slab is based on how much steel is left in the slab, because we all know that steel will, slowly rust and disintegrate. Yep. So I mean, I know we're talking about radio isotopes or whatever they are, as opposed to steel, but we all understand a slab, a concrete slab, and the steel inside. And then the question, I guess, is, well, did it actually have steel in there in the first place, or did they just put some sort of rust in there in the first place? Or
yeah, that's right.
Yeah, or was that just in the concrete mix in the first place? Or does it actually always rust at the exact same speed? So there are all the questions that come out of the amount of metal left in a slab.
Yeah, that's right. And did they put fresh steel in? Or did they put steel in that was rusty? Did they put steel in that had a plastic coating on it? So there's all those questions that come up which affect how fast it would rust away, and that's exactly what happens. And so that's how it works. But the scientists, they try to do it and be responsible, and to do it logically, but it's impossible to actually make a measurement based on just making measurements in the present. The only really way to know how old it is if you've got a historical reference. Maybe there's there might be a foundation stone connected with the building, and so the foundation stone's got a date on it, and so you can know how long it's been in there by looking at the date on the foundation stone. So that's historical method is the way of actually knowing the age of something, and that's, as creationists, that's why we say that the Bible is a reliable historical record of what happened on the earth, and so that's where we start, and we use that as our way of calculating the age. But it's very important to know the issues about radioactive dating, and a lot of people have a lot of questions about it. It just seems to be so sort of unnerving, intimidating, that people sort of just are baffled by it, and so they sort of think they have to give in and accept the dates that are mentioned.
Well, it almost sounds like, the word itself, radiometric dating, it sounds, like you've got this little machine that you just like put on it, a bit like a compass, and it just sort of goes blah, 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 and it tells you how old it is.
Exactly right. That's right.
Yep.
It's like there's an image behind it, perception. I don't know how you'd call it, but that's the way it goes. And I mean, it does, like the dates and that come out, they do have some use. There seems to be some pattern behind them, and so they can be useful, the same as if you put radioactive isotopes sort of they put them in a water pipe to try to trace where the water pipe goes, and so you can measure the way they go down the pipe, and so they use them as tracers. So that can be used. These isotopes can be used as tracers with rocks to be able to sort of identify similar sorts of rocks because they've got the similar isotopes in it. But they don't actually give the actual age, the absolute age, which they call it. But there's a lot of different methods that are used, like potassium argon. I'll mention that. That's the one that's used a lot. where potassium decays into argon, and argon is a gas like neon. And so what happens is that the people, that is based on the assumption that argon being a gas, if it's inside of a molten magma, like is in Hawaii, the lava that comes out, so the lava is molten and any gas would come out. So there wouldn't be any gas in it, in the rock, when it actually solidifies, crystallizes. Mm-hmm. So that's the assumption. And it's a reasonable assumption. And so they do the calculation based on that. But over and over and over again, what happens is the rocks actually do have argon in them when they crystallize. And so they've got a term for it. They call it excess argon. It means it's more argon than you'd expect based on the age that we thought it was, So they
based
call it
on what we want
argon.
it to be. Wow.
Yes, that's right.
Yeah, and it sounds like this radiometric dating is actually the wrong words. It should be radiometric volume, because you're measuring the volume of an isotope as opposed to a date of the isotope.
That's
right. Like saying, I'm going to measure the length, with a ruler. I'm going to tell you sort of how hot something is. It's you're using the wrong instrument. But
that's right.
They've got the wrong word there, because it's not actually a dating instrument. It's a volume instrument.
That's exactly right. It's a volume instrument, or it's a concentration instrument, or something like that. Exactly right. It's measuring something else. That's a good way of putting it.
Wow. That is awesome. Now, Dr. Tas, we've got to go into a bit of a break. Now, I will just say to everybody out there, you can go to creation.com at any time and get answers to all sorts of questions, because Creation Ministries does have an absolutely brilliant website. However, while we have Dr. Tas online, and of course Dr. Tas he's super smart, Bachelor of Science, Earth Science, first class honours. While he's here, if you have a question, it's a great time to ask. And if you have a question, chances are somebody else has the same question. If you'd like to send your questions through, just send them through to our text line 0401 949 949. That's SMS 0401 949 949. We'll come back to Dr. Tas very shortly. We have Dr. Tas Walker on the line with us at the moment from Creation Ministries International, who's really given me a much better idea of what radiometric dating is. And I just asked him off air, was my example of, rusting concrete good? And he said, yeah, that was a great example, because that's sort of what they're looking at. They're looking at something that's decaying, which is like it's rusting. So, people who know what a concrete slab is, for us, it's probably the closest example that we can visualise of, how these scientists look at stuff inside rock and how much it's decayed over time. And Dr. Tas, and of course we're talking about how, that's not a very good way of dating something. You're actually measuring a concentration or a volume of something as opposed to date. But there's all these other methods. You look at these carbon-14 dating and relative dating and absolute dating and thermoluminescence dating and fission track dating and KR dating, and it goes on and on. They've all got the word dating in there. And in so many cases, like even uranium, thorium dating, they're actually measuring a concentration of something within a rock as opposed to an actual date. There's no machine that can give you the date, just the concentration of something that's in there.
Yeah, that's exactly right. So they measure the concentration, and then basically to calculate a date, you have to sort of make an assumption as to how you think that particular thing got to be where it was, and so you have to assume that at the beginning. And if since you didn't see it happen, you really don't know how it got there. And if your assumption, you do the calculation, and if the date comes out to be different from what you expected, it creates a bit of a problem. And so you might say, that assumption was, we don't think that's right. We think it's probably more like this. So they change the assumptions, so to explain away why it didn't come out the way it was supposed to be. And so that's the way it goes. And people, they are, how would you say, they're bluffed by it in a way. My colleagues might not like me saying that, but they're a bit bluffed by it. And, but part of the way they're trained, people who do this work, is they're trained what they call to interpret the results. And so they get an age, it might be 150 million years, and they'll look at it and say, well, that's pretty good. I was expecting somewhere like that, and so it's 150 million. Or they might get an age of, say, 150, and they think, I was expecting this to be 500 million years. So, there must be something that's happened which has changed it, so that we've actually lost some of the elements of it.
Wow.
Or they might sort of think, I was expecting it to be 20 million years. And so they say, okay, so that's because there has been some contamination. So they come up with, it's called interpreting the result, or they'll come up with an explanation, a story, a narrative, to explain why the date didn't come out the way they thought it should be, or why it is where it is, and it's really okay. It's just been changed by something else. Yeah,
so that's the way it works. The thing that confuses me is, like, with the example of, let's see how old a slab is based on how much rust is in the steel. I always sort of question, okay, well, you're assuming there was no rust there in the first place. Okay, so you have all these assumptions, but then the day that it is all completely rusted, it might be like that for a long time, and that period you can't measure. And the day before you put the steel in there, before there was any rust at all, what was there then? And that always confuses me. Like, well, what was there the day before? Well, why didn't it start the day before, or the year before, or 100 years before? If you're telling us the planet's billions of years old, well, why didn't it rust billions of years ago? These questions keep coming up in my mind, but why don't other people think about the same questions?
They do. Yeah, well, the geologists work out, a little story, a little model, as to how it happened. And so the explanation would be, for example, with potassium-argon dating, that argon's the gas, they would say, okay, well, the rock melted, it was molten, it was runny, like honey or something like that, and because of that, the argon came out. There was no argon in it, and so what we're measuring is the time when the rock actually solidified. When it went hard, and no argon could escape after that. That was from decay. So that's what they're sort of measuring. That's what the assumption is. But if the number doesn't come out to be where they think it should be, they'll say, well, that mustn't quite be the way we assumed it was, and so they don't actually put that in their papers. That's what they think, that it's not what we assumed it was, but they don't actually write it that way in their papers, as if they're casting any doubt on the reliability of the dating methods.
Well, the other question then I have is, we look at textbooks that show how, certain, little creatures were so deep in the layers, and then the bigger creatures were not as deep, and different creatures, they get bigger as you go up, and you see this sort of whole, I guess, age of skeletons or of what's left over at the end of it, like sort of images on rocks. But then that theory is saying, okay, well, the bottom rock was molten, and it very slowly, started sort of cooling. It goes the wrong way.
That's right.
But you're saying, it was molten there, but then just up there it wasn't molten, and then just over there it wasn't molten, and then that one, wasn't molten anymore, but that one was molten. You know what I mean? And the whole straight up and down thing where they say, the older and the smaller the creature, the deeper it'll be. That it sort of doesn't make sense.
Not always like that. No, that's right. The way they sort of we can work out like the rocks is you'd see this slab of concrete with the rust in it, So you've got the slab of concrete, and it's sitting on some other, it's sitting like in the yard where the carport is, and it's sitting on other rocks. So you work out, you can know that the other rocks are older than the slab of concrete. Do you know what I mean? So you can work out the relative ages of them, and that's what geologists do. They work out which rocks are older and which are younger, and they can work out the order. And generally they're very careful on that, and that's something that people who creationists can agree with. We agree with what's observed, and so when something's observed, we say, "Yep, we agree with that. We can see that too." But it's when it's interpreted as being millions of years old, we say, "Well, I don't agree with that. I don't agree with the assumptions that you make." And so we agree with the order, but not with the assumptions of the age. And so we use another way of working out the age of things, and that's we assume biblical flood was the key thing there.
Yeah. Yeah. Now, when it comes to carbon dating, again, are they using an instrument to find a date? It's still just finding a concentration, aren't they?
That's right, the concentration of carbon-14 that's in the sample. And carbon-14 is a radioactive form of carbon, and so they make a measurement of that, and it's quite an interesting method. But the interesting thing is that this carbon-14, it decays a lot quicker than some of these other isotopes, these other elements that are used, like potassium, argon, samarium, neodymium, and that sort of thing. It decays as carbon-14 decays a lot faster, and so even if it was accurate, it could only measure up to about 100,000 years because it just disappears. So, but the problem is, again, you don't know how much carbon-14 was in the sample when it formed, like it's in a tree trunk or in a leaf or in a piece of coral, something that was once alive. So it's a guess. And they make assumptions. They assume that the atmosphere's always had about the same amount of carbon-14, but it was all disrupted at the time of Noah's flood, when there was volcanic eruptions, putting carbon dioxide into the atmosphere, when limestone was forming, and so that took it out, and so plants were ripped up, and so the whole carbon balance was disrupted at the time of the flood. And so you just can't make a calculation assuming it's always been the same. So we make a correction. Generally it's all right, but there's a lot of, how would you say, if you make the correction, it can be useful, but there's a lot of traps that people discover as they're going through with carbon-14. Yeah, but the interesting thing about carbon-14, this is a very fascinating thing, is that it's supposed to all disappear. It should all disappear, 100,000 years at the most. And so creationists have taken diamonds, which is carbon, and they've sent them off to be analyzed for carbon-14, and you would expect nothing left because they're 1 billion years old, and actually discover there's carbon-14 in them. And so that happens so frequently in things which are thought there should be none in there, and there's carbon-14, which is evidence that it's not that old. But of course, because it's happening in the past, somebody can say, "Oh yes, that's because," they make up a story as to why there's still carbon-14. Oh, because of this or because of that. And so, in other words, you can get any age you like depending on the assumptions you make.
Yeah. Wow. Well, yeah, I can see now that, I always wondered, we knew a little bit about carbon-14 dating or carbon dating, but when it came to, these other radiometric dating methods, I always wondered what that instrument was. And look, I found that the most interesting thing today, that really all they're doing is they're just measuring a concentration inside something else, in a rock in particular.
That's right.
And then coming up with a theory as to why there would have been more or less over time.
A little model. That's a little model. And the interesting thing, carbon dating and these other methods, radiometric dating, they all depend on the radioactive decay of certain isotopes. So they're all the same. They're all basically the same, and they've all got the same problems. It's just that the people will choose an isotope that's going to suit what they think it should be. So carbon-14, they'll choose it for something which they think is under, say, 30,000 years of age. But anything that they think is older than that, they wouldn't use carbon-14. because so the answer you get depends upon the samples you take, depends upon the method you use.
So has there been
treatment.
geologists that have used different methods and come up with different ages?
Well, that happens, but there's an article which is on the creation.com which explains why conflicting dates don't upset them, and how they explain them away. So, for example, that's all in the interpretation. So you might measure a volcanic rock granite, and you might do it with potassium argon, and you might get a certain age, 500 million years. And you might use samarium neodymium, and you might get an age of 800 million years. And you might use another method, and you get a different one age. And so what they'll say is, oh well, the oldest age is the date of the rock that melted. The other one is when it crystallized, and the next one is when it was heated by a subsequent heating event. So they develop a story which can explain every date, and that all sounds very plausible and
why they're all different.
And they're all different. They're all different, and people come away thinking that's amazing because it's the story that convinces people.
Wow. Well, Dr. Tas Walker, another awesome week, and I thank you. Our time's already up, and I've probably still got more questions, but we can go over those next week. I believe we've got you again next week. Is that correct?
Next week, I think it is. Yeah, that should be really cool. Good on you, Mick.
Excellent. Well, we're looking forward to it already. Dr. Tas Walker from Creation Ministries International, we thank you. And, of course, if anybody out there has any questions, you can go to creation.com and get your questions answered there, or send them into our text line, and Dr. Tas can give us an answer next week. That text line or SMS line is 0401 949 949.